Hi, this is Kaya, and today we're going to be talking about map projections. A map projection is the way that the 3D surface of the Earth, which is kind of a sphere, is translated onto the 2D surface of a map, which can be very difficult, so there are lots of different types as people try to figure out different ways to do that accurately. Sadly, you can't really do it accurately without having a globe, and those are pretty bulky, so we have lots of different map projections that we use, and they are distorted in one of four ways, or a combination thereof. There is the shape of an area, the precise angles and lines that actually make up an area may look different on a map projection. Distance between areas, for example, oceans might look less far apart than they are in real life. Size/area, which is where the actual, size of the thing can be distorted depending on where on the map it is, and direction, which is where it might look like two things are on the same, say, latitude or longitude, but they're really not. There is something called the Tissot's Indicatrices, which use circles on maps to represent the distortions that they have, and it is compared to those circles when placed on a globe. The first projection that we're going to be talking about is the Mercator projection. As you can see, it should be a very useful projection since it's a rectangle, which is, very convenient. However, one of the major complaints is how much size is distorted as you get towards the poles. For example, it makes Greenland look like it's the same size as Africa and about 3 times as big as Australia, which it's not. You can see by the Tissot's Indicatrice that the circles in the middle are very small or regular, whereas the ones at the top and bottom are huge. That means that there's a large size distortion. Shape and direction are greatly preserved though, so it is a map projection that is still used. As you can see, the longitudes, or the meridians, are all vertical and they're evenly spaced, but the size distortion is caused by the latitudes, which get increasingly far apart as you go north or south. Now we're going to be talking about the Robinson projection. This is called the compromise projection because each of the 4 distortion areas are distorted just a little bit. It's useful for relaying information across the oceans, and since more space is allocated to the oceans for it to be useful for that, land areas are smaller, and they're more distorted towards the poles. As you can see in the central band, there's not that much distortion, but towards the poles, there's a lot more distortion. So those are all the map projections that we're going to be talking about today. I hope you enjoyed it, and I hope you learned something. Bye!